Okay, now for the next part. Please excuse, those of you who are watching this video, please excuse the fact that there's sort of weird pauses. It's largely because my students are actually choosing to answer my questions while I'm recording this video, and they are outside of microphone range. And the other thing is, please excuse my spelling because it's atrocious, and I'm going to redo these videos later for spelling and better things. So, we've covered our first basic things in trigonometry. The next thing that we need when we're dealing with our right triangles is we need to understand the Pythagoras theorem. Now, the Pythagoras theorem most commonly is remembered by students using this very simple description of a squared plus b squared equals c squared. If we want to use the formal wording of it, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This formula allows us to calculate the length of a hypotenuse or another one of the sides of the triangle if we're given previous information. I'm just going to use as an example the classic 3, 4, 5 triangle. Now obviously this is not drawn to scale. We're going to designate this as being 3 centimeters. We're going to designate this as being 4 centimeters. And we're going to calculate c squared. So given that a squared plus b squared equals c squared, our a is 4 centimeters. So that's 4 squared plus 3 squared equals c squared. 4 squared is 16. 3 squared is 9. C squared 25 is equal to c squared. Now we want just c by itself, so here what we're going to do is we're going to find the square root of both of these, and we're left with c equals 5 centimeters. This is our basic use of the formula. Given two pieces of information, a and b, we can calculate the length of the third side, c. Now, the other thing that we're occasionally called to do when we're using the Pythagoras theorem is we're not going to be given sides that are quite so elegant or easy to use. So in our next example here, we're just going to randomly assign some numbers, make it a little bit more complicated. We're going to say that b is, well, let's make this a nice isosceles right triangle. Let's say that both of these are 4.5 centimeters. So b is 5 centimeters. Let's make my math easier. And a is 5 centimeters. I totally missaid what I was going to say, and now I've messed up this video recording, but hey, that's life. We're going to say that this side is 5 centimeters long. We're going to say that this side over here is 9 centimeters long, and in this instance, a is our unknown variable. So again, we're going to write out our formula. This is always our first step. A squared plus b squared is equal to c squared. Here we've been given b is 5. A squared, that's our unknown. C is 9. And then we just work this out. A squared plus 25 is equal to 81. Now this is the part where this becomes a two-step calculation as opposed to one step, or sometimes called a two-step problem. I need to get rid of my 25. Now to get rid of my 25 in this instance, this is plus 25, so I am going to subtract 25 from both sides of my equation. A squared plus 25 minus 25 equals 81 minus 25, because we have to do the same thing to both sides. Our 25s cancel out. A squared is equal to 81 minus 25. 81 minus 25 is 61. Minus 1 is 60. Minus 4 more is 56. Yes, I'm doing the mental math out loud. Now, I'm going to call upon one of my wonderful students here to calculate for me the square root of 56 so that I know what A is. What is the square root of 56? It is roughly 7.48. So I'm going to round that to make my life easier, to 7.5 centimeters. Is this right? Well, if I wanted to determine if this is right, and this is the same thing whenever you want to determine if a mathematical equation is correct, we plug the numbers back into our formula and we see what happens. So in this instance, it's again a squared plus b squared is equal to c squared. A squared in this case, we believe it's roughly 7.5 squared plus 25 squared equals 9 squared. That's not 25 squared. Oops. And of course, I'm totally messing up this recording. And I've gone way over time on this one. So let's try that again. 7.5 squared plus 5 squared equals 9 squared. 9 squared is 81. 5 squared is 25. Can one of my students do 7.5 squared, please? What's 7.5 squared? Doody. 56.25. So 56.25 plus 25 is equal to, so yeah, it is approximately equal. We're a quarter over. 81.25. So yes, when we include for our rounding error, that is the correct answer. So that's our basic use of the Pythagoras theorem.